Hi guys, welcome to the decision tree and random forests lecture using Scikit-learn in Python. After learning the key concepts on decision tree and random forests in the theory lecture, let's move on and use another famous dataset on heart disease in Cleveland. The original and full dataset is a part of UCI machine learning repository, and it contains 4 databases: Cleveland, Hungary, Switzerland, and the VA Long Beach. This dataset was donated to UCI repository in 1988. The original database contains 76 attributes, but all published experiments by machine learning researchers refer to using a subset of 14 of them. In particular, the Cleveland database is the only one that has been used by the machine learning researchers to this date. In the original database, the goal field refers to the presence of heart disease in the patient. It is integer valued from 0 to 4. Experiments with Cleveland database have concentrated on simply attempting to distinguish presence from absence. We are also using Cleveland database in this section. You can download the original one from UCI website or use the one provided along with this course. I recommend using one which is provided in the course material because it is already cleaned for the missing data. A new column target is also added with N for 0 and Y for 1, 2, 3, and 4, mean the presence of heart disease. If you are interested to know more about the databases, you can visit UCI Machine Learning repository for the heart disease data and read more about this dataset. However, the information on the 14 attributes that we are going to use is provided in the notebook. The attributes we are going to use are age, sex, CP is the chest pain, T-rest BPS is the resting blood pressure, CHOL related to cholesterol, FPS is the fasting blood sugar, and a couple of more features. Let's move on to the Jupyter Notebook and learn by doing. So as always, let's import the required libraries first. So import pandas as PD, import numpy as NP, import seaborn as SNS, and import matplotlib.pyplot as PLT, and then matplotlib inline. Let's run this cell, and we are done with importing the required libraries. Let's read the dataset into data frame df. So df equal to pd dot read csv, and the file is provided with the name hd, and if you press tab you will see the file hd cleveland underscore data underscore clean dot csv, and this is the file what we are going to use in this lecture. Let's run this cell, and we have our data frame in df now. As always, let's check the head of our data frame, df.head, and run this cell. And here we have age, sex, CP, which was the chest pain, and columns related to other features. The last column is target with yes and no. Yes mean the presence of heart disease, and no mean absence of heart disease. Let's add few cells and call info on our data frame. So df.info and run this cell. We see that we have 297 entries in our data frame, and there is no missing value. As mentioned earlier, I have already dealt with the missing values in the file which is provided in the course material. So let's move on and call describe on our data frame. df.describe describe. You can always press tab for autocomplete. Let's run this cell, and here we have the basic statistics on our data frame. So we have count 297 entries in each column, mean for each column, standard deviation, min, max, and so on. Let's move on and do some exploratory data analysis. We want to know how many persons in the database were diagnosed as a heart patient. Let's grab the target column and call the value counts. So df target dot value counts and run this cell. So 160 persons were diagnosed with the absence of heart disease, whereas 137 persons were diagnosed with the heart disease. Let's move on and see how many male and female were diagnosed with the presence and absence of heart disease. We can pass in hue equal to sex and call the count plot from Seaborn. So SNS dot count plot, pass in X is target and hue equal to sex, and our data is DF, and let's run this cell. Here we have 1 is for male and 0 is for female. So most of the men were diagnosed with the heart disease. So moving forward, let's see how age is related to the cholesterol. We can call joint plot from SNS. So SNS dot joint plot and pass in X equal to age and Y equal to CHOL, which is the cholesterol, and our data frame is DF. And let's run this cell, and here we have a pair plot. Age is along x-axis and cholesterol is along y-axis. We see some trend here. We see that with increasing age, the level of cholesterol is getting higher in the patients or in the persons. If you want, you can do more exploratory data analysis so that you get even better understanding of your dataset. I will encourage you to ask questions to yourself and get more familiar to the dataset. Our focus is machine learning. Let's split the data and move on to the machine learning part. The approach we are going to follow is, we are going to start with a single decision tree and then compare the results with random forest. But the first thing is, we need to do the train test split. So let's import train test split from Scikit-learn dot model selection import train test split. Run this cell and separate the features in X, df dot drop target along axis, which is 1, and our Y is df target. Let's run this cell, and now we have features in capital X and target in Y. Train test split, I will press Shift Tab and copy this code just to save some typing. Let's set test size equal to 0.30 and leave the random state equal to 42 and run this cell to get the test and train samples. So we will start with training a single decision tree. For this purpose, we need to import decision tree classifier, which is a part of tree in Scikit-learn. So let's do another import from Scikit-learn dot tree import decision tree classifier. Let's run this cell and add few lines. We need to create an instance for decision tree. So D tree is going to be the instance for decision tree classifier. If you press Shift Tab here, you will see the options for the parameter that you can pass in. I'm going to use default values at this stage. However, if you want, we can move down and explore more on these parameters. Like criterion is the function to measure the quality of split. We are going to use the default value. And if you move down, you will see maximum features, max depth, minimum sample split, and so on. Let's move on with the default values and run this cell. The next step after creating an instance is to train our model on the training dataset. For this purpose, we need to call fit on our instance and pass in the training dataset. So d3.fit, pass in xtrain and ytrain, and here we have trained our classifier. And these are all the default parameters that we are using to train our model on the training dataset. The next step is always predictions and evaluations. So let's get the predictions in pred. So pred equal to d3 dot predict and pass in x test and run this cell. And now we have predictions from our model in pred. We have the observed values in y_test, and now we got the predictions in pred. We can print classification report and confusion matrix. Once again, we need to import classification and confusion matrix from Scikit-learn.matrices. So let's do another import here. From Scikit-learn.matrices, import classification report and confusion matrix. And let's run this cell. And as usual, we are going to use print function here to print classification report and confusion matrix. So print classification report, and we need to pass in the observed values, which is y_test, and the predicted values, which is in pred. And print confusion matrix, pass in y_test and pred, and let's run this cell. And here we have our classification report. Our precision is 0.68, recall 68, and in our confusion matrix we are getting some mislabeling here. It looks like we are doing quite good using a single decision tree. Let's try random forest model on the data and compare our results with the decision tree model. Random forest is under ensemble class in Scikit-learn, and we need to import random forest from ensemble. Let's add few cells and do the import from Scikit-learn.ensemble and import random forest classifier. Let's run this cell. So the next is we create an instance. Let's create an instance RFC equal to random forest classifier, and if we press Shift tab, we see the default value of n estimator is 10. There are range of other parameters that you can play with, but we are going to use all the default values and passing in n estimators equal to 100. So let's copy n estimator from here and pass in equal to 100. You can always change the n estimator and see how the model is behaving and how the results are different with changing the number of estimators in your model. Let's run this cell, and the next step is training the model. So we need to call fit on RFC now. So rfc.fit, pass in xtrain and ytrain and run this cell, and now we have trained our model. The next one is predictions. Let's get the predictions in rfc_pred equal to rfc.predict and pass in x test, and let's run this cell. and now we have predictions in RFC underscore pred. Now we need to evaluate our model. Let's print classification report and confusion matrix. So print classification report, pass in y-test and RFC pred, and then print confusion matrix and pass in the observed values which are in y-test and the predicted values from our random forest classifier or random forest model, RFC underscore pred, and let's run this cell. So here we have. It looks like the random forest has given the improved results over a single tree for the dataset that we have used in this lecture. We got better precision, recall, and F1 score using random forest, and there are less mislabeling in the sample. You will see that if the dataset gets larger and larger, the random forests will always do better than a single decision tree. In the current situation, the dataset is not very large, but still, random forests model works better than a single decision tree. However, the model will overshine with larger datasets. So this was all about decision tree classifiers and random forests. Let's have a quick overview, and then we will move on to the next lecture where we will do the project using another real dataset. So the first thing, we did some imports and then read the data into DF. We got summary on the dataset and basic statistics, and then we tried to do some exploratory data analysis. Then we imported train test split and separated our data to features and target. And then we splitted the data into test and train datasets. We imported the decision tree classifier and created its instance. Using default parameters, we trained our classifier on the trained dataset. And then we did the predictions using X-test, which is the test dataset. We printed the classification report and confusion matrix and learned that the decision tree is doing okay, but doing quite a lot of mislabeling. The precision, recall, and F1 scores are also low. Moving forward, we imported random forest classifier, passed in estimator equal to 100, and then trained our classifier using default parameters on trained dataset. Then we did the predictions and printed classification report and confusion matrix. We learned that random forests have improved the predictions over decision tree, and we got less mislabeling using random forest classifier. Once again, I want to repeat that the random forest model overshines with larger dataset. The bigger the dataset is, the random forest model will do better job as compared to the single decision tree. So guys, go through this lecture once again, try to understand each and every step. In the next lecture, we are going to practice our skills on decision trees and random forests using another real dataset. See you in the next lecture. Good luck.